So today we're going over Chapter 7, Section 2, Properties of a Parallelogram. So a parallelogram is a quadrilateral with two pairs of parallel sides. It's a parallelogram. And to write the name of a parallelogram, you use that symbol. So kind of like a square symbol. You guys, if you need to draw it, you can do it like this. It doesn't have to be perfect. Just something that you're able to tell that it's a parallelogram. Now in this case, we have parallelogram ABCD as an example, and AB is parallel to CD. That's always true for a parallelogram, and same for BC is parallel to DA. Again, that's always true by a parallelogram. This is by definition, okay? So, by definition. So now we have Theorem 7.3 and Theorem 7.4. Theorem 7.3 is parallelograms opposite side theorem. So that means if a quadrilateral is a parallelogram, then its opposite sides are congruent. So that is the theorem. The hypothesis is shown right here in the square. And that means that the sides that are red, so these right here, are going to be congruent, as well as the blue ones are going to be congruent to each other. So the red with the red and the blue with the blue. And then for 7.4 theorem is parallelogram opposite angle theorem. Means that if a quadrilateral is a parallelogram, then its opposite angles are congruent. So that also means that these two angles right here are congruent. And these two angles right here would be congruent. It's always going to be the opposites, so AC and BD in this example. Same for the lines. It's always going to be the ones across from each other. That's not going to change. It's always the case for parallelograms. So we have now Theorem 7.5 and 7.6. Theorem 7.5 states parallelograms consecutive angles theorem. It says if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So what does that mean? We know that these angles are congruent, which are across, but now the angles that are next to each other, like this, the ones that I'm putting the arrow with blue, are going to be supplementary. If you guys forgot what supplementary means, they add up to 180. So we have angle A plus angle B equals 180. The measure of angle B plus the measure of angle C equals 180. The measure of angle C plus the measure of angle D equals 180. And the measure of angle D plus the measure of angle A equals 180. That's always going to be the case, just it has to be the angles right next to each other. That is the key part right there. So consecutive, that is the key word right here. That's the word you want to remember when doing supplementary angles in a parallelogram. Now for 7.6, parallelogram diagonals theorem. That is, if a quadrilateral is a parallelogram, then its diagonal bisects each other. So and then we have a little diagram, parallelogram diagram bisects each other. So as you guys can see, because you guys know the definition of a bisector, either segment bisector or angle bisector, it means that it's always going to be congruent. So that's going to tell us that if they bisect each other, AZ and ZC are going to be congruent. Same for BZ and ZD are going to be congruent, which is what we have written down on the right side of the square. Just remember, they bisect, so it means they're going to be congruent within each other. So let's do example 1. We have parallelogram ABCD, and they want us to first name all pairs of parallel lines. Second, name all pairs of congruent angles. Third, name all pairs of congruent segments. All right, so we gotta name all the pairs of parallel lines. As we know, the parallel lines are these. So the parallel lines are going to be AB is parallel to DC, as well as BC is parallel to AD. Now we have to name all pairs of congruent angles. Now for all the pairs of congruent angles, we know it's going to be A and C, and angle B and angle D. Now because we have those diagonal lines that are intersected, you have to write them the long way. You can't just say angle B and angle D, or angle A and angle C. We're going to have to write it out as angle BAD is congruent to angle DCB, and angle ABC is congruent to angle ADC. As well as, you guys might have not noticed this, but in a different color, I am going to write it in. These angles are vertical angles, so these angles are also congruent. No. So I'm going to write them in red up here. So we have angle BEA is congruent to angle DEC. And we also have that angle BEC is congruent to angle DEA. So you can't forget about those vertical angles. There's more congruent angles, which I will do in a different color. Since we have those parallel lines and we have those diagonals, which are transversals, this has to do with your test that you guys were having a hard time with. You're actually going to get these to be congruent because they're alternating to your angles in both cases. I'm doing it in different colors to try to keep some sort of order. So we have, again, more congruent angles. We have angle, I'm going to say ACD is congruent to angle CAB, as well as angle ACB is congruent to angle CAD. And then in yellow, I'm going to change the color for the other pair of angles. It's going to be angle DBA is congruent to angle BDC. And we also have angle DBC, which is congruent to angle BDA. So all of that is just for answer number 2. Now we have to name all of congruent segments. Now congruent segments are not that many more, but based on the theorems, we know BC is going to be congruent to AD. We also know BA is going to be congruent to CD. We also know the segment bisectors, so BE is going to be congruent to ED. And we know that AE is going to be congruent to EC. Now, I am going to write that down. Those last two are because of the diagonal bisectors. So we have, I'm going to start with BC, I guess. BC is congruent to AD. We have AB, which is congruent to CD. We also have the diagonal segments, which are BE are congruent to ED. And we also have AE is congruent to EC. All right, so now we have example 2, which is RSTU is a parallelogram, and they want us to find X, Y, A, and B. Now, I'll do A with you guys together, and then I'll let you work on B on your own. Now, for A, we have these two angles. Remember, they are congruent, so we can say from right off the bat, yes, that X equals 280. Now, because these two angles are supplementary, I can say that Y plus 80 equals 180. So I get that Y is equal to 100. Now, I don't think we have A on the first one. I can't find A. But B, we know it's going to be congruent to this segment. So B is going to be equal to 9. It's okay. I don't see A, but we'll make A happen. We'll put A down here. So since we don't know what A is, we know it's going to be congruent to this 6, this two segments, so A should be 6. I decided that A is going to go there so we can find all 4. Now, please take a minute to work on B. All right, so for B, we're going to find X, B, Y, and A. So let's start. We have that, remember guys, these two are parallel. So these angles are congruent. So therefore we can say Y is equal to 45. As well as this segment is congruent with this segment. So we can say A is equal to 12. Because we know the segment bisectors are the diagonals, this segment is congruent with this segment. So we know B is equal to 9. And lastly, we have to find X. Now, X is going to be this whole angle right here. And the only way we know what it's going to be is we can figure it out by doing X plus 35 plus 45 equals 180, because those angles will be supplementary. If you guys remember. So we're going to combine the 35 and the 45, and I get X plus 80 equals 180. Then I'm going to move it over, and I get that X is equal to 100. All right, and for C, we have that this segment right here is congruent to this one, and these two segments are congruent to each other. So to find Y, I can say 3Y plus 4 equals 13. So I'm going to move the 4 over, and I'm going to get that 3Y is equal to 9. I'll divide by 3, and then I get that Y is equal to 3. Now, for the X, I'm going to do 4X is equal to 8. I'm going to divide by 4 on both sides, and I get that X is equal to 2. For example, 3, they want us to find the perimeter of the parallelogram PINE if PI is 12 and INN is 8. So the first thing I would recommend you to do, guys, is to draw the parallelogram to the best of your abilities. Mine apparently is this. And I'm going to write P, I in the same order. N and E. Now they're telling us PI is 12 and IN is 8. Alright, so since we know that PI and EN are congruent, I can say this is also 12. And because I know IN and PE are congruent, I can say this is 8. Now, in order to find the perimeter, it's just the addition of all the sides. So it's 12 plus 8 plus 8. That's going to give me 40. So the perimeter equals 40 units. All right, guys. So for example 4, they want us to write a 2-column proof. Given A, B, C, D, and G, D, E, and F are parallelograms, they want us to prove that B and F are congruent. So let's think about it. B and F are these two angles, right? So we want to prove those are congruent. We know D and B are congruent in the parallelogram because they are across from each other, as well as we know this other angle EDG is congruent to F because they're across from each other in a parallelogram. Now, I don't know if you guys noticed, both parallelograms are in a vertical angle form. So we can use that in order to prove that these two angles are congruent. I'm going to add a new page to do the proof, but keep the image in mind as I don't have a lot of space here. All right, so I'm going to write statements and reasons. So we have the first one is the given, so it's going to be A, B, C, D, and G, D, E, F are parallelograms. I'm just going to draw parallelograms. For 2, we can say what I just mentioned, that angle CDA is congruent to angle B. And we also know that angle EDG is congruent to angle F. I forgot to write given on the right side. My bad. We also, that for this one, we know that those are congruent because parallelograms, opposite angle theorem. Opposite angle theorem. So just remember that if it's stated that it's a parallelogram, we can use any of the properties that we know that are true in order to prove it. In this case, a parallelogram opposite angle theorem will be the one to prove that the angles B and angle CDA and angle F and angle EDG are congruent. Now that we proved that, we can say that angle CDA is congruent to angle EDG because they are vertical angles, right? Now, I don't know if you guys noticed, we can substitute those angles with angle B and angle F. So for the fourth step, we can say that angle B is congruent to angle F by substitution. Now substitution will come from these two statements, and here we can grab the B and plug it into here. We can grab the F and plug it into there. That's where the substitution comes from. So we have three vertices of a parallelogram, W, X, Y, and Z. This is for example 5, where W is -1, -3, X is -3, +2, and Z is 4, -4. They want us to find the coordinate of vertex Y. Now, the first step would be to graph this. So I am going to add a picture of a graph. Now, it kind of took over the whole slide, but you guys have the coordinates, or if you need them, please look back at them. So they're telling us that X is at -3, right here. They're telling us W is at -1, -3. We have Z is at 4, -4. Then how do we find Y? So we know it's going to be the same difference based on the slope. So if you guys figure out, we can find the slope for the XW. We can do rise over run. So we can do 1, 2, 3, 4, 5 down, and then 2. So we got -5,2 or -5/2. And if we actually move up and to the left, we're going to find where Y is supposed to be. So 1, 2, 3, 4, 5, 1, 2. So this is where the Y vertex should be. You guys can either find the slope of WX the way I did, which is rise over run, or you can use the formula, if you guys remember it, M equals Y2 minus Y1 over X2 minus X1. I chose to do rise over run as it was easier since I pulled up the graph. We gotta plot the points like I did, 5 points up from the Z and 2 left. So we figure out that the vertex for Y is at 1, 2, comma 1. So that is where the vertex of Y is. Now we can also do it finding the slope of WZ, and we'll just go from X to Y. If we do it that way, just to prove you guys it doesn't matter, we rise -1, and then we run 1, 2, 3, 4, 5. And if we do that from the X, we go down 1, and then 1, 2, 3, 4, 5. It would also make us land on the Y. So it doesn't matter which slope you find, as long as you follow the same order in the same direction that you found it. That should give you the point in the Y. Now, because this is a parallelogram and it is told to us that it is a parallelogram, we can just count it if you have a graph. If you don't, draw it out and then get the slope and then do the slope for the other point if you don't want to graph it. Just a reminder, guys, you do have homework.
Again?